So based on everything we've learnt so far, what if I told you that we no longer need data types? For example, we don't need a video game object data type. We don't need a list data type. We don't need a string array data type, not even an int double or a character. And everything's fine and the software will compile. What the hell is going on here? Well, let me introduce something completely different now. In this tutorial, I'm going to be talking about the var keyword in C#. It looks something like this. If you haven't watched my previous tutorials on the dynamic keyword, where I talked about dynamic type checking and also static type checking, all that good stuff, then I highly recommend you watch those before proceeding with this tutorial. Otherwise, you're going to have a harder time understanding the concepts highlighted in this tutorial. So what is the var keyword? How does it work? Well, we can use the var keyword when defining something like a variable, for example. We have an integer variable here and we set it to 55. We could equally set this as a var, what looks like a var data type. However, var is not a data type. The keyword var is shorthand for, okay, figure out what data type this actually is when you compile your application, for example. So all checks using the var keyword are done at compile time. Now remember in our last tutorial where we talked about the dynamic keyword and how everything to do with the dynamic keyword was figured out at runtime. For example, do the methods exist? Do the properties exist? And then it kind of links it together in a late binding at runtime. Well, the var is done at compile time. So for example, if I try and call a method on a var variable, for example, then it's going to error if the method doesn't exist. But we're going to cover that later. So let's take a look at a small example using the var keyword, and then we'll go from there. So let's take a look at a couple simple examples right now. Here I have a local variable here called test, but rather than giving it, say, an integer or a string or something like that, I'm using the var keyword here. And as I mentioned before, it's up to Visual Studio and the compiler to work out what data type this is. I say Visual Studio because I've just defined the variable here, and if I hover over it right here, you can see it thinks it's an integer. If I change this to a string, it doesn't really matter what's in there, it can be empty. I hover over test, and now it's a string data type. So what it does, it works out the data type based on what you initialize it to. So I've initialized it to a string here. You can see when I hover over it, it's a string data type. And just like before, it could be an integer or even a double, for example. So now it's a double. And now when I actually compile the application, this is where it works out if anything is valid or invalid based on what you've done. So this is the compile process, and this is where it actually figures out what data type it is, so at compile time. So that's a simple example there on how var is not a data type, but you can see it actually bases its data type on what you initialize it to. So what happens if I don't initialize? Well, that's not possible. You can't actually define something with the var keyword and not give it a value, because then the system cannot work out a data type from this. So whenever using the var keyword, you always must initialize it. And from that, it can work out what data type it is. For example, a string. So the process of working out the data type based on the initialization value, well, there's a fancy word for that, and it's called type inference. So you may hear that in the future. It's called type inference, and that's where we kind of guess the data type based on the initial value here. So now our local variable here, the type is a string because this is based on the initialization value here. What we cannot then do is then just convert this to a totally different type. You can see here, cannot convert type int to string. Once this is initialized, for example, this is now a string, it's pretty much a string for its lifetime. We can't just then, okay, make it an integer, make it a boolean. We cannot do that with the var keyword. Let's take a look at an example with some more complicated objects now. So for example, let's define a game object. And this is our video game class where we just pass in some sample values here. You can take a look at the class here. There's not much going on. Private field, a constructor, and a sample method. What I'm going to do is just call this sample method here called getPublisher. So back out here, I'm setting up a new video game object, but I'm storing this in a game right here, which uses the var keyword. So now, using this game object, you can see I have full Intellisense here. I have the full Visual Studio help, unlike the dynamic keyword, because remember in the last tutorial when I talked about dynamic, everything is figured out at runtime. So we have no Intellisense at all. Because all of this is figured out at compile time, then I have full access to the Intellisense. So I'm not going to make typos, guessing methods, calling methods that are perhaps private, and I'm calling them outside of the current class. So I'm not going to make those mistakes like I perhaps would using the dynamic keyword. So if I run the application now, you can see I'm getting the publisher no problem, and I have full access to the Intellisense available. So let's talk about a few pitfalls of using the var keyword. What can't I do with it, and why is it bad, for example? Well, unlike the dynamic keyword, var doesn't really have that much disadvantage or much negative impact. However, there are a few disadvantages. For example, we cannot use the var keyword with methods. So here I have a test method here. If I try to return something of var type, it's not going to let me. Similarly, if I use it as a parameter and just give it a name, again, it's not going to let me either. This is just simply because Visual Studio doesn't have enough information available to guess the type based on a return or a parameter, or at least that's what I'm led to believe. But you cannot use the var keyword as a parameter to a method or even return a var from a method. It's just not possible. But with the dynamic keyword, for instance, you are able to, but you cannot with the var keyword. Let's take a look at one more potential disadvantage of using the var keyword. Now let's clean up some of this stuff here. So what I'm going to do, say for example, I want to create some financial software. I want it to calculate money, but I want a high degree of decimal accuracy. I don't want to lose money due to my software of not allowing enough decimal places. It's quite easy to do. So in an instance like this, I need a decimal data type. If you remember my early tutorial where I talked about decimals, I talked about floats, and I talked about doubles. And if you remember, decimal has the highest degree of accuracy, so lots of decimal places. Doubles are somewhere in the middle, and floats have the least precision, so the least number of decimal places. So I want a decimal because I'm working with money. I don't want anything to get lost. So I'm going to create a new variable. It's going to be using the var keyword, and I'm going to call it money. Now I'm going to initialize this as maybe just, it doesn't really matter what value, for example, but I'm going to put maybe something like this. Actually, no, let's just make it 0. So I've initialized it as 0, and now if I hover over this, you can see it's assumed the data type is double. Now, double is like a medium degree of accuracy, but there's no error. There's nothing wrong with this. Syntactically, it's perfect. The application runs. I'm outputting 0 right here. Now the system doesn't know my intention. The system doesn't know I want to create an application based on money. I actually want a high degree of decimal places. I want this to be a decimal behind the scenes. So how do I do that? Well, when defining a decimal, you need to just put M right there. And if I hover over money, you can see it's now a decimal, not a double. But you can see that's just human error. I could easily forget to write that M, and now I have a double. So maybe if I compile my software, give it to my clients, they start using it, for example, then they notice a little bit of money is missing due to rounding because this is assumed to be a double. So I'm losing a lot of degree of accuracy. So by making that tiny mistake, this software is responsible for losing money, and that is not good. And again, you might not be losing money, you could be gaining money, but the fact is it's wrong. So I could easily forget to use this M here and get a decimal. So it is something you should be really careful with doing. So I'll just highlight this to you now. If I just set this money value to a high degree of decimal accuracy because we're working with money, when I run the application, you can see all of this accuracy has been truncated, so quite a lot of information is missing. And that's just for the fact of using an M right here. So, it's quite easy to do. Whereas if I were to define this as a decimal to begin with, and then I do something like this, then you can see there's a red line. So the software won't even compile. There's an error, and it's pretty much saying, okay, if you need a decimal, you have to use the M suffix here. So I'm never making that mistake if I explicitly define this variable money as a decimal data type. So that is one particular scenario where using a var keyword could create problems in the future. I want to show another example now to do with the var keyword and a potential disadvantage of using it. So here I have my video game class right here. It has some various fields in here. What I'm going to do, I'm just going to copy these fields and move them into the main method right here so I can illustrate something. So what I have these various types here. I have integers, strings, list of integers, and also a game object as well. So what I'm going to do, rather than have these data types here, I'm going to replace them all with the var keyword, and you'll notice something. So when I change game info to use the var keyword, now we have to give it a value. Before, we could kind of just leave it like this, what's called null. It has no value. And we'll talk about null in a later tutorial. But now it actually needs a value because it needs to work out the data type from when you instantiate the object. So now we can't leave this empty like this. We need to give it a value. So that is one important thing to note when using the var keyword. We have to initialize it. So what I'm going to do, I'm just going to change these into the var keyword so we can see one more thing as well. Now the other disadvantage, maybe potential disadvantage, or at least awareness, is that when looking at declared variables here, it's kind of hard to tell what data type these are. Maybe we can kind of figure out console is a string and title is a string, etc. But rating, we can see the 0 and kind of know it's an integer. But using this rating, especially anywhere else in the application, we would have to hover over the variable each time and kind of work out that it's an integer. By looking at this name alone, and obviously there's var next to it, so we don't see the int data type either, it's a little unclear at a first glance what data type this is. Perhaps we can be more careful with our variable names and maybe call it rating int or perhaps rating number. And then we know from a first glance that, okay, it's a number. It's especially useful when debugging, but it is just something to note when using the var keyword, especially declaring the variables here. This kind of explicit information with regards to the data type has disappeared. We kind of really only have the initial value to look at, or we have to hover our mouse over each one just to get clarity on what data type it is. So when you have large, complicated pieces of software, and you're trying to debug, hundreds of variables, it can be quite time consuming to work out, what type the variable is, and maybe there's a type issue. Maybe you're trying to feed a string into an integer, for example. If that's a potential bug, then it can take, a little longer to work it out when we don't have explicit types here, and we're kind of having to hover our mouse over each one to work out what the type is. And by no means it's a deal breaker, it just forces you into a good habit of naming your variables correctly. So for example, a variable called rating number could be a better name than just rating. It gives a bit more information about the data you're storing in this variable. So if anything, it teaches you to be a better developer. So the last thing I want to talk about is, when should I use the var keyword? Should I ignore it completely and just kind of retain it as a bit of knowledge? Or shall I use it all the time? Are there any downfalls? Are there any practical reasons? Well, a lot of people actually use the var keyword for everything. I've looked at software and they don't even use data types, or at least hardly ever. Everything has the var keyword. I mean, there's nothing really wrong with that, especially if you use descriptive variable types. You're quite cautious about when you define decimals and floats, for example. So there's nothing really wrong with using the var keyword. You can use the var keyword for pretty much everything, or you can use standard data types. It's up to you. But there are a couple situations where the var keyword does have a few advantages. So let me show you those now. So let's clear out some of this example here. And let's say, for example, we're creating a piece of software that manages a bunch of video game stores. So we have our video game class here, and each store that sells video games will have a list of video games in their collection. So it will look something like this. However, we want to manage multiple stores. So each store will have a list of video games, but perhaps we want to catalog what every single store has. So in a situation like this, we would have a list of video games. And that will be like the ultimate game collection, for example. So in this case, look at this data type here. It's quite long, it's quite annoying to write, it's quite complicated to look at even. You could even expand that by saying I have a list of a list of a list. So, you know, the kind of predicament goes on. You can see how big that is. But in a situation like this, you could use the var keyword, and that just simplifies all of that. It saves a lot of typing, and you can see you have a nice handy shortcut there. So in cases where you have quite large data types here and you don't want to type it all out, and for whatever reason Intellisense isn't offering it up to you, or maybe you want to loop over it and you don't want to write out this whole data type, it's quite easy just to use the var keyword. You know, it's no problem at all. And you know, in cases like this, you're not defining decimals or doubles, and there's a risk of maybe losing decimal precision, then something like this is perfectly fine. It's quite an easy way to do it, and you can see how quickly it was to type just 3 characters on the keyboard versus all of this here. So just one example there. There's a couple more examples as well, which we haven't yet covered, but we're going to cover one of them. So one of the 2 examples is something called link queries. And another example is creating anonymous objects, which we will be talking about soon. And the var keyword is very good for creating anonymous objects. But to summarize, and the takeaway from this tutorial is var is not a data type. Var is just a nice way of saying, okay, let's figure out the data type based on the initialization. And this process is called type inference. So this is the var keyword in C#.